Okay, let's give you guys some more practice. So will this integral converge or will it diverge? And by the way, as x increases, this line will actually head towards zero. It's just you can't see it because the screen is too small. But as you make x to be really, really big, the line will actually head towards zero. Okay, so well, anyway, will this converge or will it diverge? So press pause and have a go. Okay, so to do this, we ultimately want to compare this to 1 over the square root of x. So we ultimately want to do something like this. We want to compare it to 1 over the square root of x and show that, well, if you look at the square root, 1 over the square root of x, show that this area here from whatever to infinity, because this thing here diverge, then this being greater or equal to this must also diverge. That's our ultimate aim. We need to compare it to 1 over the square root of x. But as things stands, we can't really say that this thing will always be greater or equal to 1 over the square root of x. We can't really say that because if you look at the natural log of x looks something like this. This here is 1, and then at e, this thing here will be 1. Now beyond e, then you can say that beyond e, if you look at just a natural log of x, beyond e, then you can say it is always going to be greater or equal to 1 over the square root of x, because this thing here beyond e, this thing here will always be greater or equal to 1. But as it stands here, we are integrating from 1 to infinity, As it stands in this region here, we cannot make this comparison where we can say that it's always greater or equal to 1 over the square root of x. Beyond e, then yes, but then between here, well, between 1 and e, we can't really make this statement. So we need to break it up. We need to break it up. Hang on. So let's break it up from 1 to e. But by the way, it doesn't have to be e. You can break it up. So this is 1, and then this is e. This here is 1. You could break it up as 87 if you wanted to. But let's choose somewhere nice and simple and convenient. Let's select e. So let's break this up. From 1 to e, and then from e to infinity. Now this thing here is going to give us a definite area. It's going to converge. It's going to give us a definite area. It really now boils down to whether or not this will converge or if it will diverge. So now looking at this, we can now make the comparison in the region e to infinity. We can now definitely say that this thing will be greater or equal to 1. We can now say that this whole thing here will be greater or equal to this whole thing here. Well, in the past, we've already established that, well, this should be ingrained in your mind. 1 over x, hang on, this should be ingrained inside your mind by now. 1 over x, you see, when it's to the power of 1 here, is a critical value here. But if this thing is less than 1, which it is in the case of square root, which is x to the power of half here, the graph will look something like this. Now this thing here will diverge. It will diverge from 1 to infinity. It will diverge. We've seen this in the past many times, and you should know this by heart. This thing here will diverge. But now we're at e, and as it turns out that e will also diverge. It doesn't have to be e. It could be let's say 97. From 97 to infinity, this thing here will diverge. And if you don't believe me, then set it up. Well, investigate for yourself. You should be able to realize this. Even if it doesn't have to be 97. It could be 204 and 63 or whatever. From here to infinity, it will diverge. So we can compare this to this. From e to infinity, this whole thing here will diverge. Well, if this thing here diverge, this being greater or equal to this, if this thing diverges, then this must also diverge. So going back to here, this is what we want to know. We'll break it up into this integral plus this integral. This integral is going to come to a definite area. We don't care what it is. It's going to give us a definite number. This thing here is going to diverge. So you've got a definite number plus something that keeps on growing and growing and growing. Then that means the whole thing will just keep on growing and growing and growing. So for example, let's just say this has an area of 42, and this thing here, this area keeps on growing and growing and growing and growing. Then you combining the two, it will mean that this thing will keep on growing and growing and growing, meaning this thing here will diverge. Okay, so this thing here, this integral here will diverge. Okay.